We will discuss October-November 2022 paper 61762 for this video. Right, in this video, so we will start with question number 1. Okay, so for question number 1, they give us a random sample of 10 mature trees, okay, of a certain variety are given below. So these are the data that we have. They want us to find the unbiased estimates for the population mean and also the variance of these heights of all mature tree for this variety. Okay, so the keyword will be the unbiased estimates. Okay, so what's the formula for unbiased estimates of population mean and variance? Okay, generally it will look something like this. It's basically provided in the formula booklet. You can have a look, okay, from the formula booklet. If I write it out, basically the population mean, the unbiased estimates for population mean should be the summation of x divided by n. The summation of x is from the sample, right, divided by the total number of the data. And then for the unbiased estimates for variance, the formula basically should be 1 over n minus 1. And then I'm having summation x squared minus summation x, the whole thing squared, divided by n. So basically, this is the formula that we should apply in this question number 1. All right, so we will start with the calculation. Okay, so first of all, we want to find out the mean. And it should be summation of x. So we try to add all the value in the data here. We just add them together, right? So we should have the summation, which is 62.1. And we are having 10 data in total, so divided by 10. Therefore, the unbiased estimates for the mean should be 6.21, which is quite straightforward. And now we go to unbiased estimates for population variance. All right, so for the variance part, 1 over n minus 1, that means I'm having 1 over 9. We try to get the summation of x squared, where we try to square the x. So I take 5.9 square, then plus 6.5 square, then plus 6.7 square, and we continue until the last data. So when we square the x and we sum it up, we will have 387.05 minus summation of x means that we already get it in first part, right? 62.1, and then I need to square it and divided by the total number of data, which is 10. Okay, so from here, the variance value that I get in the fraction form, it should be 1409 divided by 9000. And then if we change it become decimal number, it should be 0.157, correct to 3 significant figure. Okay, so this is how we get the unbiased estimates for mean and also variance. So question number 2, there's a spinner with 5 sectors and then each printed with a different color. Okay, then these two persons, Susma and Sanjay, wish to test whether the spinner is biased so that it lands on the rate on fewer spins than it would. Okay, so fewer spins. To me, the fewer is a keyword to help us to form the alternative hypothesis later. All right, so this is an important keyword here. And then Susma spins the spinner 40 times and she finds that it lands on rate exactly 4 times. All right, so the 4 times here basically is the observed value, and we are going to use it to calculate the p-value later. So this one is observed value. Okay, and then they want us to use a binomial distribution to carry out the test at 5% significance level. All right, so to carry out the test, basically, first step, we need to find out the null hypothesis and alternative hypothesis. And because they are talking about the probability, whether the we are talking about whether the spinner is fair or not, right? So they are related to probability. Therefore, to test for the probability, test for the p, we are going to use the binomial distribution. That's why. Okay, so we are going to test the p and fewer. So fewer means that the probability is less than, right? So for alternative hypothesis, it will be p. Fewer means less than it would if it were fair. So that means originally they are having 5 sectors, right? So if let's say it is fair, then suppose the red color, the spinner will land on the red color, which is 1 over 5. So they suspect that it is less than that, fewer than that. So we will have P smaller than 1 out of 5. Alright, and therefore our probability, okay, for alternative, for null hypothesis will be P equals to 1 over 5. So this is what we want to test. Okay, so for this part, the alternative hypothesis, basically it means that the spinner lands on rates on fewer spins. So that's the basic meanings of this alternative hypothesis. Okay, and then since they're asking us to use a binomial distribution to carry out the test, right? So I'm having X is binomial distributed with the total number of spin is 40, and then the P that we are using is 1 over 5. And now we have to calculate our p-value. So to calculate the p-value, I need the observed value here. So 4 times is the observed value. And according to our alternative hypothesis, this is a one-tail test on the left. Therefore, when we want to calculate the probability, it will be also one tail on the left. So that means I'm having 4 as an observed value, right? 40 multiplied with 1 over 5, you get the mean equals to 8. Okay, then 4 is also on the left hand side of 8, so we should fulfill the correct, which means that it is the correct sign where we want to calculate the probability for x smaller equals to 4. Okay, and then to use a binomial distribution to calculate the x smaller equals to 4, we can start from x equals to 0 first. So for x equals to 0, we'll have nc0, which is 40 c0, then 1 over 5 power 0, then the cube, which is 4 over 5 power 40, right? Okay, so of course, we will continue to calculate and add on all the probability. When x equals to 1, this is what we have. And then x equals to 2, x equals to 3, and until x equals to 4. Alright, and we will use calculator to help us. For the value that we get for this probability, basically it will be 0.0759. And please take note that basically this is our p-value. Alright, so after we calculate the p-value, to make a decision, right, we have to compare the p-value with the significance level. Okay, so I will write it out. I will try to compare them. Since the p-value, which is 0.0759, is actually greater than alpha, which is 0.05. So what is our conclusion? If you want to visualize the graph, okay, the result, right? Let's say I'm having this is the rejection region where it is actually 0.05, and our p-value is here, which is more than the significance level or the rejection region. So you can see that x, this particular line lies in the acceptance region already. Therefore, our conclusion should be do not reject the null hypothesis because it lies in the acceptance region. Right, so we do not reject the null hypothesis. Okay, so this is our decision, and of course we need to make a simple sentence as conclusion. So you can write the conclusion where there's no enough evidence to show that the spinner lands on red on fewer time. Lands on red for fewer spins. Right, so basically we need to write out the decision and of course the conclusion as well. Okay, And now we continue to part number B. So for part number B, Sanjay also spin the spinner for 40 times and then he find that it lands on red for R times. So they want us to use the binomial distribution as well, okay, to find the largest value of R so that it lies in the rejection region, okay, for the test at the 5% significance level. So what is the largest value for R that still lies in the rejection region? Okay, so we need to refer to the previous diagram that I draw here, right? So like what I mentioned, the shaded area is the rejection region, or the area part or the probability is 0.05, which is the significance level lah. And then for our value of x, for first part, right, just now we already calculate when my x is equals to 4, it lies in the acceptance region. Okay, therefore we want to test for the previous number, the 3, whether the 3 lies in the acceptance region or the 3 lies in the rejection region. So this is what I want to find out now. Okay, so I want to know the number 3 here, basically it is in the acceptance or rejection region. Alright, so from the result or the hint of part A, okay, we'll need to try out the previous value where x smaller equals to 3 for the probability. So again, I'm taking 0.0759, which is the answer from part A. So this value is the probability for smaller equals to 4, right? And I need to minus the x equals to 4 probability. Okay, and if I try to find out the answer, it should be 0.0824. Okay, so for 0.0824, if we refer back to the diagram again, right? This 0.0824, you can see that it is actually less than the 0.05 if you're talking about the area. So this shaded area is 0.05. For x smaller equals to 3, the area is 0.0284. That means it should be smaller than the 0.05. And it means that this value particularly is actually x equals to 3. And you can see that x equals to 3 lies in the rejection region. So we actually don't need to continue for the calculation anymore because x equals to 2, x equals to 1 definitely will be also in the rejection region. So the largest value for x that lies in the rejection region is 3. And for x equals to 4, you realize that it already lies in the acceptance region. Okay, so we get our answer here. So maybe we can make some comparison. For p-value, right, when x equals to 3, if you compare, it is smaller than alpha, so which is 0.05 for the probability of x smaller equals to 3. And then if you take the answer in part number 1, where the p-value is 0.0759 and it is greater than alpha 0.05 for the probability of x smaller equals to 4. Okay, so from here you know that x smaller equals to 3 or x equals to 3 lies in the rejection region and x smaller equals to 4 in the acceptance region. Therefore, the value for r that they want us to find should be equals to 3. Okay, so this is how we answer question number 2. Okay, so question number 3. Drops of water fall randomly from a leaking tap at a constant average of 5.2 per minute. Okay, so to me, right, the duration here per minute is actually a keyword to tell me that this is a Poisson distribution. Okay, so the word per minute actually give me a hint saying that it is a Poisson, alright? So for mean, lambda is 5.2 per minute. Then they want us to find the probability that at least 3 drops fall during a randomly chosen 30-second period. So we are having the mean for 1 minute and now we want to calculate the probability for 30 seconds. Therefore, the very first step is we need to try to adjust our lambda first. Okay, so 5.2 is for 1 minute. Therefore, for 30 seconds, I have to take 5.2 divided by 2. And I should have 2.6. The lambda is equal to 2.6 for 30 seconds. Okay, then they want us to calculate the probability for x greater equals to 3. And for a Poisson distribution, basically I can't get the probability for x greater equals to 3 because the value of x can be infinity. Alright, so for us, we need to use 1 minus x smaller than 3 to find out the probability. Alright, and now we have to include the probability for x equals to 1. This one means x equals to 1, x equals to 0 included, x equals to 1, x equals to 2, and do not include x equals to 3. So for the probability part, it will be 1 minus e negative lambda, which is our mean for 30 seconds. And then the first term is always the 1 when x equals to 0. When x equals to 1, it is always the lambda. When x equals to 2, it will be lambda squared divided by 2 factorial, and it will stop here. Okay, so this first term is x equals to 0, x equals to 1, x equals to 2. Okay, and then simplify it to get the answer. By right, we should have 0.482 as the answer. Okay, then now we proceed to part number B. So for part number B, highlight the keyword using a suitable approximation. Okay, find the probability that at least 650 drops fall during the randomly chosen 2-hour period. So now our duration becomes 2 hours. The mean or the lambda that we have is for 1 minute, which is 5.2 lah. So 5.2 is for 1 minute, and I'm looking for the lambda for 2 hours. So I have to multiply with 120 because 2 hours I have 120 minutes, right? From here, I will get the lambda, which is 624. And because of the lambda is more than 15, therefore we can change it become normal distribution. So for your information, right, for Poisson distribution, mean and the variance are having the same value, which is equals to 624. So when we want to write out the mean and variance for normal distribution, it will be both also 624, sorry. Okay, and now we will start the calculation for the probability. So at least 650 means that included the 650 with the equal sign, right? Okay, for Poisson, it is a discrete random variable, and for normal distribution, it is actually the continuous random variable. Therefore, we have to apply continuity correction. Right, so what is the continuity correction here? It should be x greater than 649.5. You should adjust it earlier so that it covers the area that we want to find. And next step, since we already know that it is a normal distribution, so I change it become z, 649.5 minus the mean divided by standard deviation, 624. Okay, so before you can get the probability, try to get the value of x correct to 3 decimal places. So it should be 1.021. And then to find out the answer for 1.021, right? In our table, normal distribution table, they only provide us the area that's less than the positive value for the z. So if we want to get the value for greater than, I have to take 1 minus lah. So 1.021, what is the probability for 1.021? We can have a look for the table. 1.0, 1.02, right? So it basically should be this one, 1.02, and then 1 at the back. So for the 1 at the back, what you need to do is you have to add it with the 2 at the last digit. So you get 8463. So we come back to our question. So you have to take 1 minus 0.8463. And you will get 0.1537, and correct to 3 significant figure, it should be 0.154. Okay, so this is the answer for question number 4. For each month, there's a company sells X kilogram of brown sugar and also the Y kilogram of white sugar. And then the X and Y are normally distributed. They are independent distribution with N, normal distribution. And then they want us to find the mean and also the standard deviation for the total amount of sugar that the company sells in 3 months, 3 randomly chosen months. Okay, so let's talk about the total first. That means for our calculation for all the variance and mean, right, we just add them together, total, right? So we just add them together. We maybe can calculate the total for 1 month first. After that, only we get it for the 3 months one, all right? So for 1 month, the total sugar, the mean and standard deviation for the sugar that the company sells, right? It should be x plus y. So that means on the mean should be mean of x, which is 2,500, okay? Then plus mean of y, which is 3,700, okay? And this is for 1 month. For 3 months, we also need to total them out for 3 times, right? Okay, because this is for first month, and then the second month, we have another 2,500 plus 3,700. Therefore, the third month also 2,500 plus 3,700. Therefore, to get the answer for 3 months, you need to multiply it with 3. So by right, you should have the answer 18600 kilogram. Okay, and now we try to calculate the standard deviation. Okay, so maybe before standard deviation, we get the variance first. So what's the variance for this one? Again, we are having the total amount. Total means that we add them together, where I'm having the original variance 120 square plus 130 square. And again, this is for 1 month. For the second month, you also have the same thing, 120 square plus 130 square. For the third month also, therefore you have to add them together, or you can multiply it straight away with a 3. Okay, and this is the variance for 3 months, but now they're asking for standard deviation, therefore I have to take the square root for the answer here. And by right, you should get this value in exact value, right, in exact form, or you can change it become 3 significant figure where it should be 306. Okay, so this is how we get the mean and standard deviation for the total amount for 3 months. And now we proceed to part number B. Okay, so for part number B, they are saying that the company makes a profit of 1.5 per kilogram for brown sugar. So 1.5 per kilogram for brown sugar, which is X, okay, and makes a loss of 0.2 per kilogram. So there's a loss. Oh, okay, so you have to know the difference between the profit and loss. So profit is for X and then loss is for Y. White sugar is Y. Okay, when we are talking of profit, of course we are having positive lah. Okay, we have income, and then when we are having the loss, basically we should have a minus. All right. So for this question, they want us to find the probability that in the randomly chosen month. So now they restrict it to 1 month. 1 month. Okay, the total profit is less than 3,000. So again, highlight the word total. Okay, so for total profit, you have to include the profit for the brown sugar and also the loss for white sugar. So let us start. We maybe should try to form the equation first. If we are talking about the total profit, right, basically we need to take 1.50 multiply with X, because the profit depends on how many kilogram that the company sell. Okay, so per kilogram is the profit with 150, so I have to take 150 multiply with X. And for white sugar, it has a loss, therefore I have to take minus negative 0.2, and then for the white sugar, multiply it with Y. So this is basically the equation, that the linear equation or linear combination that we can write out by using the X and Y. And now if we want to calculate the probability, we need to get the value for T first, the mean of T. So to get the mean of T, basically is 1.5 multiplied with the mean of X, which is 2,500. So go back and recall, the mean of X is 2,500, the mean of Y is 3,700. So minus 0.2, you just copy the mean of Y, which is 3,700, and we will get our mean for the total profit, which is 3010. And next, we have to find the variance as well. For the variance part, basically it is a multiple, okay, of a constant with a number, with a variable, right? multiple with a constant with a variable. Therefore, when we want to calculate the variance, we have to square the constant, which is 1.5 square, multiply with the variance for x, which is 120 square. Then for minus part, in variance there is no minus, it is always positive, therefore we are having plus, and then square the constant, and then put in the variance for the variable. So for this one, if I try to simplify, I have 33076. This is the variance that I get for the total profit per month. Okay, since x and y are both normally distributed, therefore the linear combination is also normally distributed. So we are having t also normally distributed with the mean 3010, variance is 33076. And we will start the calculation for the probability now. They say the total profit is less than 3000. Okay, so we want to calculate the probability that the total is less than 3000. So first step, since we know that it is normally distributed, therefore you have to standardize it, become z. So 3000 minus the mean divided by standard deviation. So I'm having square root of 33076. Okay, so to find out the probability from the normal distribution table, right? Please make sure that your z is correct to 3 decimal place. So I'm having negative 0.055. Again, for our normal distribution table, they only give us the probability for z smaller than a positive value z. To find out the z smaller than negative value, it is basically equals to z greater than the positive value here. And again, I have to take 1 minus the area that we get from the table. So 0.055. Let's have a look. What's the probability for 0.055? Okay, so 0.05. So we get this one. 0.055 also. So you have to add 20 to the last two digit here. So 5199 plus 20, we will have 5219. Okay, so go back to the question. We will have 1 minus 0.5219. And the probability that we get should be 0.4781. And of course, we will correct it to 3 significant figure where it should be equal to 0.478. Okay, so we have done for question number 4. Okay, so we are at question number 5 now. We are having the builders merchant sell stones of different size, and then we are having the mass of size A stones with the standard deviation 6 grams. Okay, so the masses of size A stones have standard deviation 6 grams. Basically, this one means the population standard deviation. And then the mean mass of a random sample. So mean mass of a sample of 200 size A stone is 45 grams. So the 45 here basically means the sample mean, which is x bar. And then for this one is the sample size n. They want us to calculate the probability, they want us to calculate the 95% confidence interval for the population mean mass of size A stone. Okay, so to calculate the confidence interval for the mean, okay, so basically the formula should be x minus z multiplied with sigma over square root n, and also x plus z sigma over square root n. Okay, so according to what we have here in our question, right, we already have all the value for x bar, sigma, and also the n. We need to find out the value for the z. So to find out the value of z, basically it depends on the 95%, the confidence level. Alright, so for the confidence level of 95%, okay, so it means that we want to have the center, which is 0.95. So this part is 0.025, and this one also equals to 0.025. Okay, so to get the value of z, this is the z. Okay, or you can find the negative z. Definitely, it will be easier for us to find the z, right? So to find the z, you need to find the z with the probability of 0.975. So 0.95 plus 0.025, you get 0.975. So we are looking for the Z value for the probability of 0.975. Okay, so what is the Z value for 0.975? You can scroll down to your normal distribution table at the bottom part here. Look at the 0.975 and the Z value is given 1.96. So we go back to our question. We know that our Z is 1.96. Therefore, we can straight away substitute everything into our formula. So to get the 95% confidence interval, the value should be sample mean, which is 45, minus Z 1.96, sigma is a 6, and then the n is 200 divided by square root 200. Okay, so for the upper limit, then it will be the plus. Okay, so by just using calculator, right, you should able to get the answer, and we want to correct it to three significant figure. Therefore, we are having 44.2 and also 45.8. This is 95% confidence interval for the population mean. And now we proceed to part number B. For part B, they are saying that they are having the masses of size B stones have standard deviation of 11. So again, for size B, this is the sigma, the population standard deviation. Then using a random sample of size 200 again, they said an alpha percent confidence interval for the population mean mass is found to have the width of 4 grams. So find the alpha. Okay, so we will start from here. The width is equals to 4 amps or 4 grams, sorry. So what is the formula of width for a confidence interval? So you take the upper limit minus the lower limit formula. So the width formula basically should be 2z sigma over square root n. And it is given that it equals to 4. Okay, so now we can start to put in all the value. So 2z equals to sigma, which is 11, divided by square root 200 equals to 4. So from here, I will get the value of z, which is actually 2.571. Okay, so it is 2.571. How can I use the value of z to get the alpha, the confidence interval, the confidence level for this confidence interval? We have to work backward, where just now we are given the confidence interval, then we try to find out the value of z, right? And now we are given the value of z, and you should know that z is 2.571. Okay, this is the value of z, and basically the alpha should be between negative 2.571 and also positive 2.571. This is the alpha. Okay, and since we are having the z value, which is 2.571, so what I want to do now is I try to find out this particular area. Okay, so to find out this area, I'm having the probability of z greater than 2.571. Okay, again, I have to take 1 minus, go for 2.571 in our normal distribution table. Okay, so scroll down, 2.5, 7 is this one, and then 1. So it should be 0.9949. Okay, so I have to take 1 minus 0.9949, and it should be equals to 0.0051. Okay, and to find out the alpha, we know that alpha is basically in the center, where I'm having this side same as this side, which is 0.0051, and this is also 0.0051, and this is basically our alpha. Okay, if you want to get the alpha in percentage form, then what we need to do is like we have to take alpha percentage is actually equals to, you take the total area, which is a 1, minus 2 part of the green color area. So 2 parts of green color areas means 2 multiplied with 0.0051. Okay, then multiply it with 100%. by right, you should get alpha equals to 98.98% and correct it to three significant figure. Basically, it should be 99.0%. Okay, so alpha is equals to 99.0. Okay, so we can actually use a graph to help us, okay, so that we can work backward when we get the value of z, so that we can get the alpha. Right, so this is how we solve question number 5. Okay, so let's try question number 6. We are given a diagram, and then it is the PDF of a random variable x that takes the value between -1 until 3. And it is a symmetrical graph about the line x equals to 1. Between the line x equals to -1 and also x equals to 3, the graph is a quadratic curve. Okay, so I think there are a few important information here. First of all, we know that this is a quadratic curve from -1 until 3, and it is symmetrical about the line x equals to 1. So when we know that we have a PDF, the probability density function, which is symmetrical, there's a important detail here where the mean, okay, so where the mean of this function is actually equals to the line of symmetry. So from the diagram, we know that the line of symmetry is actually x equals to 1. Therefore, the mean will be equals to 1 as well. Okay, so this is what we can get up for the mean of x. Okay, and now what they want us to do is they want us to they give us a random variable s is such that the mean of s is equals to 2 times of ex, and the variance of x, s is equals to variance of x. Sorry. Okay, so from here we actually know that the mean for s will be equals to 2 times, okay, of the mean of x, the expected value of x, and it is equals to 2. Okay, therefore the mean of s is equals to 2, which means that the line of symmetrical will be equals to 2 later, right? Then the variance of s equals to variance of x. Okay, variance or standard deviation basically measure the spreadness of the diagram. So when you're having the same variance or the same standard deviation for two random variables, right? Basically, it means that their shape is the same. Okay, it should be the same, alright, because their spreadness is the same. Therefore, if I want to sketch a diagram for s, the random variable x, so first of all, I need to know that the line of symmetrical is at s equals to 2. And then, according to what we have just now, right? Okay, for x, the value start from -1 until +3, and the line of symmetrical is 1. So for the s random variable, we also want to have the line x equals to 2 which is the mean. And then for the same variance here, basically it means that we can actually try to measure and have a look. Alright, so from the mean to the smallest value, right, there are 2 units. Okay, so from the line of symmetrical or the mean, okay, to the end of the diagram or to the end of the function, it is also 2 units. So we are going to have the same width, okay, or maybe the same spreadness for the random variable s as well. Therefore, if I want to have 2 units, then basically I will have my graph starting from 0 and then end at 4, so that I'm having 2 units and 2 units as well. And then for the shape, for the height of the graph, basically should be the same as well because the spreadness are the same. So if I have a look for this maximum point here, I expect this one should be a value which is close to 0.375. I assume that it is the center between the 0.25 and also 0.5. Alright, so I assume it is a 0.375. Okay, so when I want to sketch the random variable for s, I also try to make it at 0.375, where your height of graph should be somewhere here. And to draw it as a symmetrical quadratic curve, my random variable s will have the PDF more or less like this. Okay, so you can see that the shape should be the same, symmetrical at the line x equals to 2, because the mean of s is equals to 2 times of the mean of x. And variable value are the same, therefore the spreadness of the graph and the shape of the graph should be the same. So it will look something like this for the probability density function of random variable S. Okay, all right, then if we proceed further, we are having another random variable T where the expected value of T equals to expected value of S. So from here, we actually know that the mean value for T should be equals to 1. Okay, it also means that later the line x equals to 1 will be the symmetrical line, okay, for this function. And we are having variance, so variance T equals to 1 over 4 variance x. Okay, so like what I mentioned earlier, variance or standard deviation basically measure the spreadness of the graph. Okay, so this is my variance of t equals to 1 over 4 variance of x. If I want to have a look for the standard deviation, right, that means I have to take square root. I'm having standard deviation of t equals to half of the standard deviation of x. Okay, which means that if we try to sketch the diagram, right, the spreadness of t should be half of the spreadness of x. So it means that if let's say I'm having a look here, my spreadness of x, let's say is 2 units, I say from the line of symmetrical until the minimum point as an example, right? So if let's say I assume that for this graph, the spreadness from line of symmetrical until the minimum value is 2 units, so that means for the t, it will become 1 unit only. Okay, because the standard deviation is equals to half of the standard deviation x. So it should be smaller. Alright, the width should be smaller. So if let's say this is 2 units, then the width for the t should be 1 unit. Same thing happens for the upper part here. Okay, so if we consider everything, right, since my line of symmetrical should be x equals to 1, this will be my line of symmetrical, and then we only want to have the line of symmetrical until the minimum value, which have only 1 unit. So that means my graph will pass through 0 and also pass through the 2. Okay, so when my graph, when the width of the graph already been compressed or squeezed, become smaller value, or the smaller width, okay, we have to make sure that the height of the graph will become higher, so that the total area under the graph, right, it is still equals to 1 for a continuous random variable. Okay, so when we make the width of the graph smaller, therefore we actually have to make the height of the graph higher. So again, to get the higher point, I will refer to this original value here. This is 0.375 originally, and then I want to make it 2 times higher, because for the standard deviation I make it 2 times smaller. Okay, so I want to make it 2 times higher. So 0.375, if you multiply with 2, more or less roughly you have 0.75. So I will know that my quadratic curve basically will pass through these 3 points here, and it should be a U shape. Therefore, if I try to sketch it, it will become something like this. Okay, and this is the graph for the probability density function of t. Okay, so I think the most important part that decide the graph, the shape of the graph, basically it depends on the value of standard deviation. Alright, so standard deviation is actually half of the standard deviation of x for this variable t. Okay. Okay, so for part number C, it is now given that fx equals to this function from -1 until 3. And please take note that this is basically refer to what we have in part A just now. Okay, so basically it shows this graph, the function of this particular graph here, fx, right? Okay, so let's have a look for the detail. Since we know that this is the graph in part A, graph fx in part A, and from what we observe, right, you know that it is a symmetrical graph. It is a symmetrical graph, and now they're saying that the probability of 1 minus a until 1 plus a is equals to 0.5, and they want us to show this equation, which is the correct one. Okay, so if we try to understand the graph. Okay, we know that just now the line of symmetrical is a 1, and therefore the 1 plus a should be at maybe this point, 1 plus a, and then for 1 minus a, it should be somewhere here, 1 minus a. So that means this distance is a, this distance is also the a. So the equation for this one, probability between 1 minus a until 1 plus a, right? This whole area should be equals to 0.5. Okay, so this area belongs to 0.5 or equals to 0.5. So according to our understanding of the symmetrical of the graph, right? This small area should be 0.25. This small area also should be 0.25. So that when so that you're having a symmetrical area because the graph is symmetrical. So this smallest value is -1, this largest value is actually a 3. Okay, and then to prove this equation, I might want to use a equation, maybe a new area here, like this one, the highlighted area, because I feel that if I use this area, it might be easier for me to integrate and get the equation that I want. If I use the equation provided by them, right, I'm having the lower limit with the a, upper limit also with the a. When I want to expand the function, it might be a little bit more quite confusing, or maybe time consuming, sorry. Okay, it will be a little bit more time consuming. So I'm going to use this area, the highlighted area in yellow color, okay, to prove this equation that they want us to show. Okay, so according to this highlighted area, right, I will have the integration of 1 plus a until the value of 3 for the function given, and it is actually equals to 0.25. Okay, so now I will start the integration. I try to integrate all the terms inside. I'm having 3x plus x squared minus x power 3 divided by 3. Then substitute in the limit with 3 and also 1 plus a. If I just now, I'm using 1 minus a, 1 plus a, right? When I want to substitute into the x power 3, I feel that it is a bit long or maybe a little bit more tedious. So I try to avoid it. I will just use the upper limit 3. Okay, and it is equals to 0.25. Okay, so now let us start substituting in all the value here. Substituting the value 3. 3 times 3, I get a 9. 3 squared, I also get a 9. 27 divided by 3, I also have a 9. And then now I want to substitute in the 1 plus a into the equation. I'm having 3 multiplied with 1 plus a, negative 1 plus a squared, and also plus 1 over 3, 1 plus a power 3. And they are equals to 0.25. Okay, so again, we try to expand everything slowly. So I'm having simplify off some of the term here. Okay, and expand all the other thing. I'm having 9, then minus 3, minus 3a, then minus expand the 1 plus a squared, and also expand the 1 plus a cube. So I'm having 1 plus 3a. If you expand it slowly, you're having 3a and then 3a squared and then a power 3. And it is equals to, I will move the 3 over 22 over and multiply with 0.25, I will get 8 over 3. Okay, so again, if you try to further simplify it slowly, right, basically, you'll get this step. And after that, we make the denominator disappear. Then I will have a power 3 minus 12a plus 8, and it is equals to 0. Okay, so this is how we prove the equation that they want to show. Of course, if you want to use the limit with 1 minus a and 1 plus a also can, no problem. Alright, but to make my steps slightly easier, so I prefer to use the limit with a value, which is a 3 and also 1 plus a. Okay, so this is what we have for part C. And now let's proceed to part D. They want us to verify that the A is equals to is between 0.69 and also 0.7. Okay, so just recall back the equation that we have in part C is A power 3 minus 12A plus A equals to 0. So they want us to verify that A is between these two values. Okay, so to prove that or to verify that A lies between these two values, right, there are many methods that we can try. For me, I would want to apply some knowledge from paper 3, the pure maths, where when you want to verify the root lies between two values, right, we can use the sign change method where we substitute the first value into the equation and we try to have a look for the value. Okay, so first I substitute 0.69 into my equation and then I will get a value which is 0.0485. And then the next one is I try to substitute 0.7 into the equation as well. Then I will have negative 0.057. So when we see the sign change appear between the answer, right, one is positive and one is negative value, this one is positive, this one is negative. So we call it as sign change. So when we can see the sign change appear, okay, sign change can be seen, it means that the roots actually lies between the 0.69 and also 0.7. Okay, so this is how we solve question number 6 for this paper. Okay, so the last question, question number 7. In the past, Lakshmi's time in minutes for her journey to college has mean, okay, 32.5 and also the standard deviation 3.1. So after a change in her route, the Lakshmi wishes to test whether the mean time has decreased. Okay, so I think highlight the word decrease. This particular word tell us about the sign of the alternative hypothesis later. Okay, so she notes her journey time for a random sample of 50 journeys. Sample mean is 31.8. So the 31.8 basically is the mean for these 50 journeys, which is a small sample, which is a sample. Okay, 50 is considered as large sample, but it is a sample mean, right? So 31.8 basically is the sample mean. So the 32.5 basically will be the population mean, and standard deviation will be the population variance or standard deviation. Okay, so you should assume that the standard deviation is unchanged. So they want us to carry out a hypothesis test at 8% significance level, whether the mean journey time has decreased. So again, the keyword is decrease that help us to decide the direction of the alternative hypothesis. Okay, so we will start the test now. Okay, so first step, you need to write out the null and alternative hypothesis. We are going to test the mean time, okay, the time for the population. And the mean should be mu lah, okay, when I write it out in the symbol form, I should write as mu. The word decrease tells us that it should be smaller than the population mean that we have before, so which is 32.5. And it should be 32.5 minutes. Okay, so basically this is how we decide the alternative hypothesis. The sign smaller, we get it from the word decrease. And the alternative, the null hypothesis will be always mu equals to 32.5 minutes. Okay, so since we are having a large sample, right? So a large sample, basically what we can do is like, we know that the sample mean is normally distributed because the sample size is large, right? Therefore, the sample mean will be approximate normal distributed, where the mean should be equals to the population mean, and the variance should be population variance divided by divided by the sample size, which is 50. Okay, so this is the distribution that we have for our calculation part here, and now we will look for test statistic. Okay, so to get the test statistic, the formula will be sample mean minus the population mean divided by standard deviation over square root n. So our sample mean is 31.8, population mean is 32.5, divided by standard deviation, which is 3.1, divided by square root n, which is the sample size, square root 50. Okay, so for this part, if I try to use calculator, I will get negative 1.597. Okay, so we get a test statistic already, and now we are going to find out the critical value. Alright, so to find out the critical value, I write it as ZC lah. Okay, so for the critical value, it depends on the significance level that we want to carry out for the test. And from this question, they are saying they are looking for 8%, right? 8% significance level, which means that our rejection region will be on the left because of the sign of the alternative hypothesis that's smaller. So we're having a one-tail test and the rejection region on the left-hand side. So this rejection region, this area, should be equals to 0.088% of significance level, right? Okay, and we want to find out the critical value, which is ZC, which is at this part. Okay, so to get the critical value from the normal distribution table, we're not able to get the Z value for the probability 0.08. Therefore, we have to find out the complement complement probability lah, where you take 1 minus 0.08, you get 0.92. So we are going to look for the Z value, okay, for the probability of 0.92. So we go to our normal distribution table, looking for 0.92. So 0.92 is a probability, so we should look from the values inside the table here. So I'm looking for a value that's closest to 0.92. Okay, so I think we are having this one, 9192, right? And for 9192, you need to add the 8 at the last digit so that you can get 0.92. So if I read back the value, it will be 1.40 and then 6. Okay, so my Z value should be 1.406. Now, if we go back to our question here, according to this diagram, right, you can see very clearly that the value of the critical value should be a negative value. Okay, because it is below the symmetrical line, which is x equals to 0, z equals to 0. Therefore, the z value here should be equals to a negative value. Just now we get 1.406. Therefore, our critical value should be negative 1.406 because they are symmetrical, right? So you can straight away put a negative in front. Okay, so after I get the test statistic, after I get the critical value, then I will want to compare them, okay, and see and make a decision. Okay, so for our test statistic, the value that we get is negative 1.597. And if I want to compare it with the critical value, okay, so which is negative 1.406. Okay, if you compare that, what we get is like you are having smaller than critical value, right? If you have a look from the diagram side, it means this is value for 1.406 where it separates the rejection region and also the acceptance region. And where is our negative 1.597? So basically it will be somewhere here, which is smaller than the negative 1.406. Okay, this is our negative 1.597, and very obvious, you can see that this value, right, it lies in the rejection region. The shaded area is a rejection area, right? So it lies in the rejection region. Therefore, we can make a conclusion where we are going to reject the null hypothesis. When we reject the null hypothesis, is our decision, so we have to write out a conclusion sentence as well. When we reject null hypothesis, it actually means that there is enough evidence to show that the mean journey time has decreased. So to show next means time, mean journey time actually decreased. Okay, mean time has decreased. Okay, so this is basically how we carry out the test by using the critical value approach. Okay, so now we are coming to part 2. Later, Laxmi carries out a similar test with the same hypothesis, also at 8% significance level, using another random sample of size 50. Given that the population mean now is 331.5, find the probability of a type 2 error. Okay, so for this question, we are going to find the type 2 error. Okay, so what do we have for the definition of type 2 error? Okay, so for type 2 error, the definition is we accept the null hypothesis when the null hypothesis is false. So for the accept null hypothesis part, basically I need the acceptance region, because when the value falls under the acceptance region, then we will accept the null hypothesis, right? So we actually need to put in the acceptance region for the calculation in this part, and then acceptance region, given that the null hypothesis is false. Okay, so the very first step, actually we need to try to find out the acceptance region first. Okay, to find the acceptance region, according to the diagram that we have just now, okay, so we are having, this is the rejection region, right? And the area here is 0.08, and just now we already found out the critical value, which is Z, C equals to negative 1.406. Okay, so if I want to get the critical region or rejection region, I write, okay, so I write out here, rejection region. Okay, so to get the rejection region, basically, you know, if let's say my test statistic is less than, okay, is less than or equals to negative 1.406, then we will reject the null hypothesis. Okay, so we will reject when the test statistic, this is test statistic, is smaller than the critical value. Okay, so now I put in all the original value that we have. The original population mean is 32.5, and then we are having 3.1 smaller equals to square root 50, negative 1.406. So from here, if you try to move everything over to the right hand side, you will get sample mean should be smaller equals to 31.9, correct to 3 significant figure. And this is my rejection region. Okay, so rejection region. And we actually need the acceptance region in our calculation for the type 2 error. After we get the rejection region, right, acceptance region basically is the opposite side, okay, of rejection region, where we are having x greater than 31.9. Given that the mu now, they have changed because the null hypothesis is false. That means 32.5 is a false one. So we will use the new mean, which is given in the question as 31.5. Okay, and now sample mean for the sample size 50, it is still considered as large sample. Therefore, it will be approximately normally distributed. So when you're having the sample mean here, we need to standardize it become Z. Okay, so I use 31.9 minus the new mean 31.5 divided by the standard deviation 3.1 over square root n again, square root 50. And from here, I will get the value Z greater than 0.875. Okay, so one more time, for the area that Z greater than the positive value, if we will not get this from the normal distribution table, we will get only the Z smaller than 0.875. So again, I go back to our table, looking for 0.875. So 0.87 is this one. Then with a 5, that means you need to add 14 to 8078. So 8078, if you try to add 14 here, okay, I think we'll get 8092. That means for our area, okay, of Z smaller than 0.875 is 0.8092. So to find greater, I have to take 1 minus that. Alright, Then from here, we'll get 0.1908. Of course, I want to correct it to 3 significant figure, and my answer here should be 0.191. Okay, so to calculate this type 2 error, before it, you need to get the rejection region first. Then only you can change the sign to apply it to change it become the acceptance region in our calculation. Right, so basically we have discussed all the questions in this paper. Thank you very much for watching